Hello Atmospheric Science students, Dr. Shragi here, and we are now ready to start talking about loops in C. Now, hopefully by now you have already read that chapter of the textbook. It's pretty hard to make progress in the class without keeping up in the textbook. But you've hopefully gotten the idea about loops and how loops are a way in a computer program to make something happen repeatedly. We're going to learn a lot about loops. All the programs that we're going to use this semester have a lot of loops in them. It's one of the main techniques that we use actually in scientific computing. Loops are used to perform some action in the computer program multiple times. I mean, you can well imagine, if you had a list of 500 addresses, maybe your computer program for each of the 500 addresses will print a label for you. You can imagine that there are the ways in which we would be using these sort of loops. Pretty much any useful C program is going to have some kind of loops in them. And broadly speaking, loops in C come in two different varieties. Again, this is going to be the same in any computer language. Exactly how they do it will be slightly different depending on exactly what language you're using at your job someday or whatever. But the basic idea that there's two kinds of loops will be true. One is kind of a type of loop that runs a specific number of times. You know in advance that there are 500 addresses, and you want to, for each of the 500 addresses, you want to print a label. That's what in C they call a for loop, for, F-O-R, just because for is the command that they use to start that. For is a very common word for that kind of loop. Some languages call those do loops, but anyway, like do, D-O. The other thing is that, by the way, that could be, I'm making it sound like you know in advance how many times it's going to run. But it could be n number of times where, like, you don't know. I mean, I don't know if it's 500 or 200 or 800 addresses. I know it's n addresses, and then it'll run n times. That's still a for loop. That's in contrast to a while loop. While loops are going to be a different type of loop that runs a flexible number of times, maybe not even at all. Okay, you are going to continue to do this while something is true. While we're not at the end of the file, read the next observation from the file, that kind of thing. While means I don't know yet how many times I'm going to have to do this, maybe not even any times, but while something is true, keep doing this loop. But we'll see how all that works. Most of the time in this class, the key things we're doing though are for loops. For loops are going to be requiring some kind of counter. There's going to be a variable, typically an integer, although it doesn't have to be, including in the assignment this week. It's not going to require an integer, it's going to require a float. But most of the time, for loops require an integer that is a counter that's going to be keeping track of how many times that loop has already run. Like I said, it's usually an integer, but it doesn't necessarily have to be. Like, for example, in this little example here, I have a little loop that would run 5 times. Let's kind of take this apart line by line here. In this little loop right here, we have an integer called I. I is our counter variable here. Okay, I mean, it could have been anything. I called it I, just because it's narrow and small and fit on the screen better. The way a for command works is for, and then there's 3 arguments inside of this set of parentheses. The first one is, what do you want the value of the counter to be the first time I go through the loop? Unless there's an unusual application, which unfortunately in the current assignment it is, but most of the time, you're going to want to start at 0, and you're going to count from there. So the first time through the loop, I is equal to 0. Then, we'll come back to what the rest of those arguments are, but what the loop will be doing is inside of a set of curly braces. Like in this case, there's a pair of curly braces there that have a printf statement in between. It's just going to be printing, if you can see it on there, it's just going to be printing the value of I. Okay? That's just going to be what the loop is going to do. So typically we take the stuff that is inside the loop and we indent 1 time so that it's a little bit clear that that's like a lower level, just like on an outline or something like that. This is a step that's inside of a loop here. Alright, each pass through the loop, how should this counter change? Now by far the most common thing you want to do is you just want to have the value of that loop variable I go up by 1. Now, you might be saying, wait a minute, what is this I++ thing here? I++ is a shortcut in C for I equals I plus 1. I equals I plus 1. Right off the bat, that should seem strange. I equals I plus 1, that's not even good math, right? I mean, you can't solve I equals I plus 1, solve for I, it doesn't work, right? That's because, remember, we're using the word equals to mean set this equal. Okay, so you're saying take the value of I, add 1, and put that into I. You're just increasing or incrementing the value of I plus 1. I plus plus is actually a shortcut for I equals I plus 1, and it tends to be the way we do things in C. Why? Why do we do that? Well, it's explained in the book, but basically I equals I plus 1 takes no less math than I equals I plus 372,691. It's a fair amount of math. I plus plus, which has the same result as I equals I plus 1, is one operation in the computer. The chip knows how to just increment an integer by 1. So it is vastly faster for the computer to compute I plus plus than it is for the computer to compute I equals I plus 1. So we tend to say I plus plus. If you were using a different step for some reason, like instead of you wanted your increment to increment by 2, then you would have to put like I equals I plus 2 or something as your step there. We never actually do anything quite like that here, although I guess the homework is a little bit like that. Again, we'll walk through it. Now, the question is how many times should we run this loop? That's what the middle of the 3 arguments separated by semicolons in a for statement is for. That tells you, while this is true, keep doing this. So like for example, if I want my loop to run 5 times and I'm starting at time 0, I equals 0, I equals 1, 2, 3, 4, up, I've got them all now. So as long as I is less than 5, I want to keep going through this loop. The next time through the loop I will be equal to 5, that's no longer true and we're not going to go in it anymore. This is actually the way we tend to do loops in C. If you want the loop to run 10 times, you go from I equals 0 to I is less than 10, I plus plus. Okay, that when your first time through the loop you get a 0, and then a 1, and then a 2, all the way up to I equals 9. The next time through the loop I is equal to 10, it doesn't pass the test of I is less than 10, and it pops out of the loop. But we'll do some examples of that. So like this little example of this loop here would run 5 times. Excuse me, the hiccups. I equals 0 through I is less than 5 would be 0, 1, 2, 3, 4. This is the normal way in which we make a loop, the so-called traditional format of a for loop. There are 3 arguments, which are separated in the case of a for loop by semicolons. That's a common mistake, by the way. If you try to put them with commas, you're going to get weird errors. So for I equals 0, so like if you want your loop to run n times, where n is some integer, for I equals 0, I is less than n, I plus plus would be the way to make that happen n times. Where that first argument there is the starting value of the loop. It's mostly going to be 0 for most of these things. Then the second argument is the condition of the loop. We keep going through this loop while that part is true. And finally, that third argument is the increment. What happens each time? How do you increase the value of your counter until you get through the loop completely? This is the so-called traditional formatted loop. 99% of the loops we write in this class are going to be like that. As it happens in the homework today, you need to write one that has something like this. You can make a floating point loop. It's the same sort of thing. It's got 3 arguments. In this case, though, it's a float. Like, let's say I had a floating point number called pressure. Let's say I was trying to draw contours of pressure every 4 millibars, from 1,000 to 1,024, or 1,000 to 1,020, or whatever. I could start with pressure equals 1,000, and then as long as pressure was less than 1,024, it would do whatever's inside the loop, each time through the loop, increasing the value of pressure equals pressure plus 4. Okay, so we're using a floating point number there instead of an integer. Honestly, that's less common. For complicated reasons, when we designed the course, we wanted this assignment to have an example of that, in part because you really won't have very much more like that the rest of the semester. One of the things that can be inside of a loop is another loop. In fact, that's a very common thing in atmospheric sciences because that's great for working with grids of data. I mean, you know, if you have a grid of data that has 25 rows and 57 columns, you could say, you know, for each row, for row equals 0 to row is less than 27, and for each column, from column equals 0 to column is less than 57, then each time through that loop, you would have, for each of the rows, you go through all the columns, and then you'd move on to the next row, and you do all the columns. Pretty slick, okay? Nesting loops is a very good trick for working with grids of data, and there's just a little example there of a nested loop to help you get the syntax right, but we're a ways away from getting to nested loops. I wouldn't get just too bent out of shape about that until we get to the second half of the class. The other kind of loop that we will be working with from time to time is a while loop. While loops are the ones that when you don't know in advance how many times to run the loop, including potentially not at all. It's just going to keep running until or while something is true. Like here's a little example here. We're going to have some kind of control variable, a variable that will have some value in it. Let's say in this case I have a variable called temperature f, temp f, and it's going to just be set to 0. While temperature f is greater than -98 in this program, the things between the pair of curly braces are going to keep happening. Remember, curly braces group together commands. So, is it true? I originally set temp f to 0, while temp f is greater than -98. That's true. I wonder what this program is doing. Oh, well then what's going to happen is the stuff on the inside of this loop. Now, notice again, we indent to show that this is like the inside of the loop. What's going to happen here? It's going to print, please enter a temperature in Fahrenheit that we're going to convert to Celsius, or enter -999 to end. -99 to end. So the user will enter a temp f, you'll do the calculations there to compute temp c from temp f, and then you're going to print it. But what's going to have happened if the user entered -99? Well, it'll actually go ahead and compute a temperature of, try to convert -99 Fahrenheit to Celsius, and then it'll come back through and say, while temp f is greater than -98. Is -99 greater than -98? No, it's not. So it will fail that test and break out of the loop and move on to the next part of the program. While loops tend to be used to trap errors. Or, like for example, some of the problems you're going to have coming up later in the semester. You're going to prompt the user to enter a temperature, and then you're going to prompt the user to enter a dew point. Well, what if they put a dew point that's higher than the temperature? That can cause all kinds of problems in some of the calculations we're doing. Well, we're going to have to be careful about that. So once they've entered, let's just call it temp f and dup f for temperature in Fahrenheit and dew point in Fahrenheit. Well then, while temperature is less than dew point, print, I'm sorry, but your dew point has to be less than your temperature, try again. And then ask them again for a temperature and ask them for a dew point. And that's the end of your while loop. Well, probably most of the time the user's not even going to hit that, right? Most of the time they're going to wisely put in a temperature and a dew point such that the temperature is bigger than the dew point, and they won't even, while temperature is less than dew point, it's not. It'll skip that loop and move on to the next line of the program. You'll see lots of examples of that in the textbook and throughout the rest of the semester. That is probably our main use of a while. Today what you're going to be doing with a for loop, though, is you're going to be computing a table of wind chill temperatures. You're going to be prompting the user to enter an air temperature and a wind speed. No, you're going to prompt the user to enter a temperature, and then a lowest wind speed and a highest wind speed, and an interval. So you're going to be making a little table, like for a temperature of 10 degrees Fahrenheit, so you'll have this, what temperature do you want to enter? 10 degrees. What's the lowest wind speed you want? Well, let's say 0 miles per hour. What's the highest wind speed you want? Maybe 30 miles per hour. What interval do you want? 5 miles per hour. Then it'll compute, for a wind speed of 0 miles per hour, this is the wind speed. For the wind speed of 5 miles per hour, this is the wind chill. For the wind speed of 10 miles per hour, this is the wind chill, and so on. There's an example in the book to show you about that kind of stuff. That's what we're going to be doing with loops for this particular assignment, which does involve the somewhat strange situation of a floating point loop. But we'll be doing so many integer loops over the course of the semester, the traditional format for loop, that I think it'll be fine. Okay, I'm going to break out of this, and then we're going to go and just do some examples from you on the screen.